record. Right. So in new, we just go to hazard or chart agus and thermometer. Now, chart agus thermometer. Here we go. Right. So G calculate chart cost. Okay. Now, so this chart closer to J, now go through out is the tech cost. That is temperature. It's a measurement. Closer, right? So very important. So the question is out the exam. No, not here. Christmas, summer, you're leaving certain exams, you need to come in, especially ordinary level. Meaning that for the chast of this chart. Right, so adding going to mean down and you know should differ at the chast of this chart. What's the difference between heat and temperature? PG and short and in electricians are all engineering. Right, PG, let's have it. Maybe I had a short chance to give it what? Right, yeah, you won't show you do every chance to come in. Right. Heat is a form of energy. Temperature is a measurement of how hot or cold the body is. That's the difference. Showing a difference. Chas is a short form of funny. It's the chart the J squares the cost. That's all you write. What's the difference between heat and temperature? Heat is a form of energy, temperature is a measurement of how hot or cold something is. And you okay better. Very straightforward. Right. Funny in internal energy. Same body temperature. What's normal body temperature? 37 to 47 degrees. Okay? That's the normal body temperature. Okay? Now, let's go to carpet 37, your hands could be colder. Right? So the what's normal room temperature? 20. Okay, 18 to 20. Only once you get at normal room temperature, we always take 20 degrees. At normal room temperature. My hammers and shop, they're all trying to keep it that way. 13, 12. That's nice. Okay? Now, see? Finns det kunna solar shop. And now in the funny case and dress up to the short jar. That means my persuasion is then you be able to reach on harmony. Right? A CO2 monitor plus just as a jiggle go on from there. Plus the short got to go faster. Gone in near constant. Well. Right. Okay, we shall sort of go with not that I thought of right. Now, so the mechanics did that for you in internal energy, right? So in solid then the molini nasty the hell I was near to doubt the push hard the sea. You can't move. Means you're solid. Right? Like the hard thing to understand is every atom is made up of 99% empty space. Every atom, right? Atom was the chance for John more atoms. So everything in this room is 99% empty space. Hard after the height and hard to put this. Okay, even though it looks 100% solid, it's actually 99% empty space. Then we're not going down there yet. We'll get back to that, right? Now, which is there an atom distinctions and there are all the molecules, right? So when you're solid, as you can leave side by side, no room for movement. Okay? At room temperature. Okay? This is like room temperature. See how like this should unless if I increase the temperature. Huh? That would burn. Right? Now switch is a piece of steel that's solid at room temperature. Going to shining 4,000 degrees Celsius. What would happen to that state? It would melt and turn into a liquid. Okay? Right. So, the yeast in solid in the morning naturally helps needs to die because it's hard to see it. Because it out with clean. It can vibrate. Okay? So, these arches and chart needs smoke clear here be known. And that's why he got how he does the movement because they're able to vibrate so much that did the work. Okay? Now, we talked about funny and men or a funny car, we yelled and creepy random in the morning. So because of this random vibration, it has internal energy. Because something, anything that moves must have kinetic energy. Okay? So therefore Tyson funny electron. That's what we call internal energy. Now you search in chart to take part the small funny creole to take the morning I guess machine the small funny in man. So again heat energy is a transfer of energy. So when we blend chas, we take the heat energy from the heat and we can add it to a substance and get more vibrations, hence we can increase the internal energy. There's no okay example. So fairly straightforward. Now what's the unit of temperature? Degrees. Right? Degrees today. Celsius. Degrees Celsius, degrees Fahrenheit is what we use. Celsius in Ireland, America, Fahrenheit. What's the standard unit of temperature in reality? What should that be? Kelvin is the standard international unit of temperature. Alright? Now, I say Kelvin and in it SI the chart. Now, einstein question experiments lead to yen within. And what the yen within is the lab will always be degrees Celsius. Kelvin is the same as degrees Celsius as in just when you increase just by 1 Kelvin you go up by 1 degrees Celsius. It's just to change that per ton is that the 0 point of Kelvin is minus 273.15 degrees Kelvin or degrees Celsius. Right? Now grammar free change. Kane scale chart used go practical galway is degrees Celsius. Right? So we'll always use degrees Celsius lab. It's more practical. Okay? Now, this short temperature Kelvin. At 0 degrees Celsius, we'd actually 273.15 Kelvin. Now, Mohammed to 20 degrees Celsius, you just add 20 degrees to the Kelvin. So if has a 200, so this room temperature says 20 degrees in this, then it's equals to 293.15 Kelvin. So you just add. Now the good news is 10 values in the North table on the temperature. The chapter on monthly temperature, chapter 2, the formula to change Kelvin to degree. It's an okay. Okay? The other good news is we never, ever use Fahrenheit. Okay? Bring them to me yet right to the Holy Hall in Vegas, right? Here I'm right there. I think the hot temperature like over there. I was thinking, oh, sweltering, it's 100 degrees, but he's in Fahrenheit. Right? Now, Ray Towley, the County Luminary ring I'm at, he's a Yale, he's at 47 degrees Celsius. Right? Remember the Auburn, so there's a house and less than put. Yeah, it's a good raw heat. Right? So it's just far too hot. Like I said, Saudi machine I have the end. Like up with the times how everybody 50 degrees Celsius. Just horrible. And then you go the outing, shortest movie the sun name. 30. Shortest movie machine was 44 degrees Celsius. And was now it all depends on the atmosphere, like I said, humidity, all depends on the humidity. Like the right on with the low humidity on, it's grand. But with the high humidity on, I really actively got down with it, it's hot. Really see raw heat.
Yeah, I mean, do we think that chance or trash or
36? No, I hope to see, yeah. It's very rare in it, in mind you. Yeah. Now, making sure for global warming, heavy destinations across the Italy, Spain, Greece, all them European countries been high temperatures. Saudi Arabia, same problem happening us. Saudi Arabia, things are raw heat. And K people boy can't cope with it. Alright, so it's easy to say, nothing you really look at is all you in. Yeah, it's a bathing in such box. It's never going to burn. You can say, it's a power lot, but anyway, that's the relationship at the degree Celsius. The formula, like the formulas for speaking they go Kelvin. So these degrees Celsius is equal to temperature in Kelvin minus 273.15. Okay, so we have over here added 4 degrees to Kelvin. So let's do finish exercise 14.1. Convert the following temperatures to Kelvin. So do anything? Jolly 273.15 watt the whole lot. You can't see it. Would you okay, that's it? Yeah, like you can convert the following temperatures to degrees Kelvin. So with 100 Kelvin of it, Jolly 270. Oh, take it going this way. Take it to the sum of 273 law. So can the heat at the sum of 273 law, it down it comes from the Jolly 273. Does that make sense? Okay. Right. This is important. Thermometric properties. Thermometric properties of anything. Now, the sharper and softer look. 7 thermometric properties you need to know. Right? Now, here's what the height to keep that. What do you can start saying? Right. So you use a thermometer, potentially thermometer, yes? Yes? Right. First you can start saying, what is the thermometric property of a thermometer? Now, that's the substance, it is this a thermometer, but what's the thermometric property? Now, to understand the question, I take a look at what is thermometric property. So, here add in the thermometer, right? So, it is short case, that could be possibly just get a hope in easiness or your short question. What is thermometric property? Thermometric property talks around physical. It's the physical change property. Or B, I have an echo in toaster reality. It's something that you can measure, something that changes due to temperature, due to the heat, due to, changing temperature. So, it is something physical that changes due to a rise in temperature. Okay, so Ari thermometer are an Ari physica or B hagen echo in toaster. So that means something that we can measure reality because of temperature. So we then kind of do the thermometer or not. What changes in the thermometer when the temperature changes? Okay. What goes up or down? The mercury expands or the alcohol expands. What changes? It's the length of the column. It's my here. This has been how is it in the upper thermometer? The column book is a wee column of mercury and that rises or drops. So the length changes. So it's the length of the column is the thermometer. Do you see what's most high that left? It's what physically changes. You can see change. It's the physical change due to temperature. Okay, so this is called a column. It's the length of the column that changes due to a change in temperature. And we measure this length. We can calibrate the length to show what temperature it is. You can check. Yeah? Like you see in the experiments we're doing in wireless. We're going to calibrate. The limit thermometer you can scale a beer and then you scale it. You try to scale it. Try to water. Is it okay? Right. Now, a thermometer. What is a thermometer? So shall I take it? Thermometric property of a thermometer. Thermometric laser usually lay chart carpet. So it's an instrument to measure temperature of a body or anything. That's a thermometer. Now, in thermometer, now it's a freeze all asking projecting in this. So, thermometric property of the thermometer, right? So this change the thermometer, short this reservoir, the mercury, and then the rubber, so a hair length column, so let's freeze it, so column, and then the length changes. So, Fobrin reactor is today, so it expands. Wat een reactor vat een keel rubber, met een vat een column reactor, the remainder meeting in chart. So the length of the column in liquid will change due to the change in temperature. Change the root more left. So that is the thermometric change. That's the thermometric property of a mercury thermometer, is the length of the coil thermometer. Isn't okay? Okay? Now, so in tiny thermometer are earth one, and thermometer mercury one, I guess alcohol one. So that is the thermometric property. The length of the coil changes due to a change in temperature. So it's okay, Jan. Okay? Now, ruddy yellow. Okay, Adi thermometer, I guess thermometer. So frittier, I guess, and thermometer frittier. So these substitution in the texture, substitution we cause the length of electrical resistance, so same cause of frittier resistance, resistor is frittier, right? So frittier lecture, so electrical resistance. So adding and frittier lecture is shorter, listen chalk. So Fisic and frittier chalk the force. So the resistance changes. Now, once you real resistance is there, just understand what that means. Right? So if you get your electric current, so it flows, so your electrons flow around the circuit, right? Now, we just electron. Well, now this is your resistor. Then you run circuits are there when they go in resistor so you don't blow the fuse or the circuit or the LED or whatever when they go near resistor. Now, resistor is something that resists or slows down the motion of the electron flow through the circuit. So Kosla, best way to explain James the bony that the what the shamrock gets at when the continue be bugged, which are forest fuel punch away with the punch element and then you be bugged. That's fairly straightforward, so just fly through them. Continue be bugged so forest now with all in the sure bugged hard, which is after bugged fever. Yeah, it's really tough to move through because they got away, bump on the sound again. And that's what happens with resistors. We add heat energy to the resistor, so the circuit flow beat the chatham. There's more vibrations, and because of the more vibrations, there's more chance of kill, listen, and therefore it slows. Okay? Now different resistors have different, obviously, stronger or weaker resistivity. Okay? So frittier, so more the switch as electrical resistance, what changes is the resistance changes due to temperature. Okay, so we'll make okay listen. Now, start with the current image, force electrical thermocouple. The electromotive force of a thermocouple. So this in here, we thermometer down to electrical resistance, EMF of a thermocouple, right? So this is a thermocouple. Now we show us this lab built in the wire transfer you mad the charge and actually wire through that. So you have two types of wire. You have a copper wire and you have an iron wire, right? For to understand cold junctions, to understand hot junctions. Now, Chuck, this could be a question of we need to describe with the aid of a label diagram the properties of a thermocouple. Okay? Now, just to gather and Chuck, we'll change the temperature on it. We go from a hot junction to a cold junction, hence there's a rapid change in temperature at the reverse, right? And this produces actually an electrical current. Okay, it actually produces electricity. Now, you have to change the back, but it still produces electricity, right? So, Mark Hamilton, yeah, metal, excellent, von circuit on a yenu, where the passage I guess was Quinita, and yeah, Homer, that's the junctions, Homer. And yeah, Homer, a chart that for left, Edian FLG. Force lectra crucia, electromotive force. But a few millivolts, so in about the circuit, so to produce a couple of millivolts. Alright, can you be there with a TV show, Breaking Bad? How is it Breaking Bad? No? How is it? How is it? First season, actually, that's just the first season. First season, this is actually shot. Can you do, just to explain, can you get busy the most camper run, with the desert? See happen when the batteries leak. When the batteries leak battery, you wait and you could next to the desert, right? When the batteries leak that. And then your phone signal after you, they were out of rescue and so on. rud a hans in Easter na, a sample circuit, kind of good business at the coins, the copper coins, like, and then hot and cold junction, agus bhí a ábhar go leor power to produce that to charge the battery. Right? Right, so that's cost them a guide, can you, MacGyver, that's the one. Max H. Still MacGyver. So my age now. That's at least 3,000. What MacGyver?
Was new word.
Oh, the new version, the old version you need only got. Right. Yeah. Well, that's static charge, static build up. I'll explain that to you with that in chapter. Right? Okay. Right. Now, so these, because there's a change, a rapid change in temperature, it produces a small current. So hence produces voltage. Okay? Now, so it's feature an FLG a Horsley voltmeter, like it's Brehen Reach and FLG are an definite chart linear current. So the greater the distance, the greater the voltage curve, produces greatest difference between the two temperatures. Okay? Now, thermocouple I talked about are a glacier, like it's a feature chart of Horsley. So we can use this to measure temperature depending on the amount of voltage you can produce. Okay? So these Mohersi district communicate what's the thermometric property of a thermocouple. It's the electromotive force produced. So in the FRG it produces an electromotive force. Small voltage. So it's the voltage, change in voltage due to change in temperature. Atoms are produces in voltage. You can hear? Okay? Right. This is probably the easiest one. The coloured thermometer. That's all the biggest wall he gets it the 134 and yet passes SS in temperature to the hot. Now these which are really direct cost and shop 37 is a plus, so that should be normal body temperature. Jahanjaric means you're overheating it, displayed enough or whatever. Okay? So everything in there are crystal area, they area charted. So what's the thermal property of a colour thermometer? What changes what temperature? The colour, yeah, it's a depth. So it's depth that changes. So the colour thermometer is the colour changes due to a change. The Goni switching. There's a guy for thermometric chart intake. What physically changes what a change in temperature. Which is okay again. Okay? Right. Pinkinella, I thermometer against thermometer. Now thought gas we brew parasite. Okay, against thermometer gas. Now if I am a shot the lab where I went over to wine on the needed it. Because I would link the syringe more ago. And my HP gel is down at 100 degrees Celsius. Right? I guess I'm sending my doctor do, but when I increase the pressure, start the boiling. When you change the pressure, you can boil water at a lower temperature by changing the pressure. Water boils at atmospheric pressure, floods, right? But then when you liquid it and you change the atmospheric pressure, hence increase the pressure. The other on which time we top for a syringe, we increase the pressure, the water will suck this in this scoop gel into the syringe, even though it was initially in 100 degrees Celsius. Okay? Now, part gas we brew tarisa, thermometer gas. Now, just produce gelatin gas, so syringe, filleted cheese, to mass phosphate gas. So there's a fixed amount of gas, you see. So this is your fixed amount of gas you can chop. Right? Now, these fixed mass of gas, I guess the kind of way in the shell is capping over it. So we seal the top of it because we're getting this scutilla more gas, right? Now, to brew an atmosphere, I go up an onion, so the piston is working on ordinary atmospheric pressure. I can kill the shell percent time gas to brew pressure, so the constant pressure. So the incident syringe in this just A has been D, I guess the A fixed mass of gas as a seal, that's it at ordinary atmospheric pressure. Begin until I increase the pressure. Okay? Now, my altitude chart in gas, if we increase temperature. See how in the chamber air. What happens when we heat the air? You heating up a balloon, see how that it expands, right? So air expands when we heat up the air. Which is the air? There's a solid air, there's a leak, like a leak, and you can blow out air even if we have to add the air, because it's solidified. Alright? And it changes to that air, you keep warming up, then you do a hot air balloon. Highly recommended, right? But a hot air balloon, right, after heating the air in the balloon, hot air rises. So it expands and it rises, right? Now, what air would in the air in charge? It's got a higher than piston. It will start to push up, right? So therefore we increase the pressure to keep the mass fixed. Okay? So the third gas we brew tells you on the area thermometer. The constant pressure changes. You can show the thermometer car. Right, anyway, you can show you the shower. You can show you the shower model. We should need just one experiment, but we should change the day.